Alright, we're now going to try and plot a sine function, and at the end I'm going to give a few pieces of advice that I learned the hard way. So let's just do the easy stuff and then we'll beat on the other. Alright, we've got the same fig plot style and AX, so that we'll have a figure that has the white grid in the background and the axes. And then I'm going to define a fill list from start to stop, and this is really LST for list, is an empty list. While start is less than stop, list1.append start, and then I'll add 0.01, and then once I've filled the list I will then return it to whoever calls it. So down here I have xval equals fill list minus 6 to 6. So xval will then be a list that was filled from minus 6 to 6. And now I define y as an empty array, or an empty list, and for n in xval, so n is each number, and what I will do with that is I will calculate the sine of n and append that to y, and then I'm going to graph the x values against y. So this will be minus 6 to 6, and it will be sine of each one of those numbers. So if I save that and run it, there I have a nice sine curve. Now you'll notice that it doesn't come all the way down to 0, because pi is 3.14, so 2 times that is going to be 6.28. So if we make a minor adjustment and say that this is going to be minus 6.3 to 6.3 and run it again, notice I go just a little bit below 0, so I don't care as long as I get a pretty good looking sine curve. And strangely enough, it starts at 0, goes up to a maximum of 1, and comes back and up again. Alright, so that'll get you a simple sine curve, and I could change this to say minus 20 to 20. And the only reason I'm doing this is to say it really doesn't matter what I put in. This just means I'll get more repetitions of my sine curve. And the reason I'm doing all of this is eventually we're going to want to do this for projectile motion. And start will most likely be 0, and stop would be end of flight, or the time of flight. So we can work with that. Now, all this is very nice, and if let's bring this back to minus 6 and 6. Let's say we want to plot a second graph on here, and I'm going to have y2 is an empty array, or an empty list, and then let's just steal this, copy and paste. Now, as opposed to putting in n, the sine of n, what I'm going to do is put in n star 3. So now what I'm going to do is append and I really want to append y2, I'm going to append n cubed into y2, and then what I want to do is steal this, paste, and this is then going to be y2. So now I should have a graph of sine and then the cube. And let's see what happens. It looks like I've got a straight line with no values on it and a cube. Well, the problem is, notice that this is going to go from minus 200 to 200. And if I choose the magnifying glass and keep coming in on this, you begin to see that it's not really a straight line. The problem is, this should go from 1 to -1, where my orange curve is going from more than -200 to above 200. It's too large a distance for this to then show up. So what can I do? Well, let's see what happens if I make this x squared. This only goes up to 35, and so now I can start seeing that, yeah, there really is a sine curve in here. And if we take it out and make it just y versus x, so I'll have a straight line, then all of a sudden it looks a whole lot better. Although I'm still got, because this is going down to -6, so how can we make it even more pronounced? Well, I could make it 1/6 times n. There you go. So I get my straight line and I get my sine curve, but my sine curve is now sufficiently sufficiently visible so I can see that it really is a sine curve. So what is the point of all this? The point of all this is you need to watch out for what is effectively the range of values that you are going to be plotting. When I had n cubed, it appears that my sine curve is actually a flat line. So you have to watch what are the extremes of your functions and will one wipe out the other. Okay. The thing that you can do is, instead of having this a sine, you can have a cosine, and if you plotted sine and cosine on the same graph, you should be able to easily tell that, and it would be good to do. You could also do, say, 3 times and see what happens if you do that. And if we're going to do that, we're going to take this one out so that you don't get wiped out by it. And if you graph sine of x and sine of 3x, you may find that there is a difference, and you should play with that. All right, enough of that fun. But we've now shown how to use fill list, how to plot, or how to get a plot of sine of x, and what happens when you have two functions, one of which effectively swamps the other one. Okay, there you go.